What if I told you that a simple game of dice could reveal one of the biggest secrets behind why some businesses just thrive and others fail? It all comes down to a number we think we understand, but we often get completely wrong. And that's the average. Okay, let's dive right in.
So, we're going to look at two different ways to roll dice. Just think of them as two different processes, maybe at a factory or in a service company. And your challenge? It's to figure out which one is better. But trust me, the answer isn't nearly as obvious as it looks. Okay, so on the left we've got process A. Super simple. We just roll two dice and add up the numbers. You can see the results plotted on this graph. And on the right, that's process B. Here we roll one die, and then we add either a 3 or a 4 to whatever we get. At a glance, they look pretty similar, right? I mean, both are kind of clustered there in the middle. And this is the million-dollar question. I'm going to tell you right now that if you ran both of these processes 100 times, 1,000 times, the average result you'd get from each would be exactly the same. So, which one would you choose? Which one is actually the better process?
See, the answer lies in seeing through this illusion of averages. Focusing only on that one number can hide massive, massive problems in a system, and that's exactly what we're about to uncover.
And right here, this is where that illusion really sinks its teeth in. Both processes have an average result of exactly 7. So if you were a manager just looking at a weekly report that showed average performance, you'd look at this and think, yep, both processes are identical, everything's fine. But in reality, they could not be more different. But here's the secret sauce. This is the hidden number that changes the whole game. Look at the standard deviation. For the 2-dice process, it's 2.3. But for the 1-die process, it's only 1.7. So even though the average is the same, the spread of the results is completely different. The first process is kind of all over the place, while the second one is much tighter, much more consistent.
So what is standard deviation? Well, in really simple terms, it's a measure of variation. It tells you just how predictable your process is. A low number, like our 1.7, means your results are always tightly clustered right around the average. A high number means they're unpredictable and spread way out. And believe me, in the business world, predictability is gold.
All right, so let's pull this out of a simple dice game and plug it into the real world, because that's where we can really see why this whole variation thing actually matters. And this quote right here, it just nails the core idea. Think about it, right? Imagine a pizza delivery service. If their average delivery time is 30 minutes, that sounds great on a flyer. But if that average is made up of some 10-minute deliveries and some 50-minute deliveries, customers aren't happy. They don't care about the average. They experience the 50-minute wait. They experience the variation.
Okay, now let's spice up our dice game a bit. Let's throw in some customer requirements. Let's say our customer is only happy with a result that's between 2 and 12. Anything that hits exactly 2 or 12 is a defect. Think of these red dotted lines as our specification limits. They are the absolute boundaries of what's acceptable.
And, well, here's the unavoidable result. The process on the left, the one with the higher variation, has results that spread out so much they're constantly hitting those defect boundaries. But the process on the right, the more consistent one, it keeps all its results safely tucked away from the edges. It's a simple rule. More variation always means a higher chance of messing up and creating a defect. So how do we formally measure this? I mean, how can we put a single number on how good a process is at staying within the lines? Well, there's actually a formal way to do it. We use a metric called the sigma level.
And you know what? Calculating it is actually surprisingly simple. First, you just find your total acceptable range. For us, that's 12 minus 2, which is 10. Then you take that number and you divide it by 2 times your standard deviation. It's basically a showdown between what the customer wants and what your process can actually deliver. And just look at the results when we run the numbers. The high variation process, it gets a sigma level of 2.1. The more consistent, lower variation process gets a sigma level of 3. It's that simple. The better, more stable process gets the higher score. So what this means in practice is that a higher sigma level gives you more room for error. Think of it like driving in a lane. A higher sigma level means you have wider lanes, a lot more buffer room before you hit the guardrails and cause a defect. And look, we're not talking about some tiny incremental improvement here. The impact of cranking up your sigma level, the power of locking in that consistency, is absolutely massive.
So, what about this number? 3.4. What does it mean?
This is the holy grail. A process that achieves the gold standard, what's known as Six Sigma quality, is so incredibly consistent, so predictable, that it produces only 3.4 defects for every million chances it has to fail. I mean, think about that. That's an unbelievable level of quality, and it's achieved not by chasing a better average, but by relentlessly hunting down and eliminating variation.
So what's the big takeaway from all this? It really just boils down to this. Getting rid of variation is often way more important than just improving the average. A predictable process is a high-quality process, end of story. And you have to remember, your customers don't live in your spreadsheet with all the averages. They experience the result they got this one time, and they're the ones who reward performance that stays inside their lines.
And that leaves us with one final thought, one question for you to take with you. Whether it's in your job, your finances, even your daily schedule, what is an average that you rely on that might be hiding a really dangerous amount of variation? What looks safe on paper but feels unpredictable in reality? Because that's where the real risk and the real opportunity for improvement always lies.